8.3 Wave equation. We want to know why it's true, how to use it to solve problems, and what does it even mean. So we saw this equation in the last lesson, v equals f lambda, or v equals lambda f. F is frequency, lambda is wavelength. Well, why is this equation true? We know that velocity is, let's say, distance over time, displacement over time, technically displacement, but it's how far it goes over time. Well, the wavelength is really the distance over one wave. Look at it that way. And frequency is really 1 over time. So the velocity is lambda times 1 over t. So that's why it's equal to f lambda. So that's where that equation comes from. So at room temperature, sound waves travel at about 340 meters per second. What's the wavelength if the frequency is 440 hertz? So frequency is 440. We want to find the wavelength. And can write an equation like this. So velocity is 340. Frequency is 440. Divide both sides by 440. 440 divided by 440 is 1. 1 lambda is the same as lambda. 340 divided by 440 is about 0.77. So we get about 0.77 equals lambda. And the unit's meters. The meters comes from here, the m. Hertz is 1 over seconds. Cancels out the 1 over seconds here. What does that even mean? In class, we calculate different examples, and we find that when the frequency is 440, the wavelength is about 0.77. When the frequency is 170, the wavelength is 2. And we gotta be careful. The wavelength is not meters per second, it's meters. Let's get the units right. When the frequency is 340 and 680. So we see that as frequency increases, as frequency goes up, the wavelength gets shorter and shorter. That's the big idea from the wave unit, and that's what the wave equation really is saying.